Today we'll be presenting on battery management system and applications of artificial intelligence in e-mobility. We'll be discussing about what a battery is and how it is worked. Also we'll discuss about different types of batteries and its working. We'll discuss about fuel cells and its working, and later we'll dig deeper into our main topic, battery management system, what battery management system is and what are the different types of battery management system. Later, we'll also be discussing on how to design a battery or how a battery is manufactured, the materials required for its designing and all. And at last, we'll be looking after the applications of artificial intelligence in e-mobility. So we'll start with what a battery is and also look after the working of a battery.
My name is Ayush and I will be explaining about the working of a battery and a fuel cells. Generally, a battery is a device that converts the chemical energy contained in its active materials directly into an electrical energy by the means of an electrochemical oxidation reduction reaction. Two electrodes made up of various metals submerged in a mild acid makeup of cell. A battery can be created by stacking many cells in series. Anode and cathode are the names of the positive and the negative terminals of the batteries. In an electrochemical cell, the chemical energy is converted into the electrical energy. This system does work by transferring the electrical energy through an electric circuit. As you likely already know, electricity is the passage of electrons through a conductive route, such as a wire. A circuit is the name of this route. Anode, cathode, and electrolyte are the three components that make up a battery. A electric circuit is connected to a cathode and an anode, the positive and the negative sides of either end of a conventional battery. A group of electrons at the anode results from a chemical reaction inside the battery. The anode and the cathode experiences an electrical difference as a circuit. This difference can be explained by a unsteady accumulation of electrons. Electrons in the image above travel across the wire, illuminating the light bulb as they do so. This is one approach to explain how electrical potential results in the movement of electrons within the circuit. The chemicals in the anode and the cathode are altered by this electrochemical reaction, cause them to quiet the providing electrons. As a result, a battery has a finite amount of power. Now, coming to a lithium ion battery, it contains a separator, an electrolyte, a cathode, and an anode. It utilizes a number of reversible oxidation and reduction processes. A discharge event disperses lithium ions, and a charging reaction transforms them back into a metallic lithium. Lithium ions and electron transport are separated by an electrolyte. The lithium ion transport number is a perfect battery will be 1. Both an excellent ionic and electronic conductor are required for the electrode system. Inside a lithium-ion battery, oxidation reduction reaction take place. Like in on the first half reactions, COO2 plus lithium plus electron gives lithium carbonate oxygen. Oxidation takes place at cathode. There the graphite intercalation compound forms. LiC6 gives C6 plus Li positive plus E negative. Here is the full reaction that left to right equal to discharging and right to left is equal to charging. LiC6 plus COO2 gives C6 plus LiCOO2. Now coming to fuel cells. An electrochemical device known as a fuel cell uses hydrogen and oxygen to create a water and heat in order to generate electricity without using the process of combustion. Hydrogen is burned in a fuel cell by combining with oxygen in a way that generates a voltage between two electrodes. The only byproduct produced is a water. We can add hydrogen either directly or as component of a larger molecules like methane as a natural gas. Now coming to a working of fuel cells. Fuel cells work like batteries only, but they do not run down or need charging. They produce electricity and heat as long as fuel is supplied. A fuel can produce energy by using the chemistry between hydrogen and oxygen both. Such a cell was employed in a Apollo case program and had two separate uses. It was used as a fuel source and as a water source. This fuel cell functioned by transferring hydrogen and oxygen into a concentrated sodium hydroxide solution using carbon electrodes. The cell response can be expressed as follows, like first cathode reactions are oxygen plus two molecules of hydrogen plus four electrons gives four hydroxide atom. Anode reaction gives 2H2 plus 4 hydroxide atom gives 4 molecules of water plus 4 electrons. Then the net cell reactions here is 2 hydrogen plus oxygen plus 2 gives 2 molecules of hydrogen. Now, the reaction rate of this electrochemical response, however, is quite low. With the aid of catalysts such as platinum or palladium, this problem is overcome. The catalyst is finally divided before being incorporated into the electrode to increase the effective surface area. Now over to my friend Harsh.
Now we are going to discuss about the section of battery management system. Battery management system is an electronic system which optimizes the efficiency and performance of batteries. So it is basically a combination of software or hardware which, taking into account various factors, uh, makes a scenario such that the performance of a battery is maximized and it can work for a longer period of time. There are many applications of batteries that we don't even know of, that is in our electronic devices, very common devices such as smartphones, batteries in smartphones, laptops and smartwatches, etc. Traditional fuels have many problems associated with it, such as the pollution and their non-renewability and etc. So therefore an electric vehicle or even a hybrid electric vehicle is a proper alternative. So basically these vehicles uses battery as their major power source. They run on electricity, but because of their mobility, a movable, a portable source of electricity is required, which comes in the form of a battery. And to get the maximum power output from this battery and to manage it in various scenarios, a battery management system is a must. For economic performance, there should be elements of a state monitoring of the battery, control of charge flow, cell balancing, and evaluation of output that should be included in a battery management system. And moving onwards, we have features of a battery management system. There should be data collection. That means there should be like how the battery is performing, what is its temperature, and what is its power output given, and how quickly it is depleted. And there are many factors such as the state of health, a state of life, a state of charge, which is needed to be monitored using various algorithms. There should be it The battery management system should satisfy various safety regulations. The temperature of the battery comes under one of those because it could be hazardous if the battery gets overheated. There should be control charging and discharging. A uniform flow of charge is very important for a proper functioning of a car. Because of the non-uniformness, the components could get damaged. The balancing cells also come under that. Cooling management is also required for safety and for proper output of a battery. There should be a functional user interface. That means the battery management system should be able to provide various output from its observation or its readings, and to get feedback or to make automated decisions so that the optimization is possible. And there comes and if all these conditions are satisfied, then you will get a long and efficient battery life. Functioning battery management system functions on various levels such as software and hardware. In software, we have safety circuitry, sensor system, data acquisitions. We have to control the charge, we have to maintain the communication, we have to manage the thermal properties of the battery. The hardware, we need to determine state of charge, we need to determine state of health, we need to balance the cells, and we need to detect the fault, and there should be a proper user interface in the forms of microcontrollers and processors and various sensors, and there should be software should be the center of the entire system as it controls the decisions made by the hardware, and all these things are not found in the conventional battery management system, which is designed for a more controlled environment rather than in actuality, which is electric vehicle and hybrid electric vehicle. The environment are not in as much control for in our hands. Commerciality and necessity. Battery management system is necessary if we really want to optimize the functioning of a car, and to get the maximum power output for the each watt of energy that we supply to the car. And that's why, for to make the electric vehicle and hybrid electric vehicle marketable to the common consumer, their performance is one of the features that the people look for, and therefore there is a need to be done many research and more more sense of more sense of curiosity in terms of making to get a proper battery management system for this to be possible.
So today I will explain about types of fuel cells. Basically, there are four types of fuel cell: alkaline fuel cell, molten carbonate fuel cell, phosphoric acid fuel cell, and solid oxide fuel cell. Alkaline fuel cell. The alkaline fuel cell, also known as the Bacon fuel cell after its British inventor Francis Thomas Bacon, is one of the most developed fuel cell technologies. Alkaline fuel cell consumes hydrogen and pure oxygen to produce potable water, heat, electricity. They are among the most efficient fuel cells, having the potential to reach up to 70%. Molten carbonate fuel cells. Molten carbonate fuel cells were developed for natural gas, biogas, and coal-based power plants for electrical utility, industrial, and military applications. Since they operate at extremely high temperature of 650 degrees Celsius, that is roughly 1200 Fahrenheit and above, non-precious metal can be used as catalyst at the anode and cathode, reducing cost. Phosphoric acid fuel cells. Phosphoric acid fuel cells are the types of fuel cells that uses liquid phosphoric acid as an electrolyte. They were the first fuel cells to be commercialized, developed in the mid 1960s and field tested since 1970s. They have improved significantly in stability, performance, and cost. Such characteristics have made the PAFC a good candidate for early stationary application. Solid oxide fuel cell. It is an electrochemical conversion device that produces electricity directly from oxidizing a fuel. Fuel cells are characterized by their electrolyte material. The SOFC has a solid oxide or ceramic electrolyte. Advantages of this class of fuel cell includes high combined heat and power efficiency, long-term stability, fuel flexibility, low emission, and relatively low cost. The large disadvantage is the high operating temperature, which results in longer startup times and mechanical and chemical compatibility issues. That's it for me. Thank you.
Let's discuss about artificial intelligence in e-mobility. Artificial intelligence is the ability of a computer to analyze and understand a problem or a situation on its own, and hence act accordingly to the situation without any human intervention. Artificial intelligence is the future of e-mobility, undoubtedly. So, before going to the applications of artificial intelligence in e-mobility, let's discuss about the need of it. There are these vehicles called autonomous vehicles which have the capability to understand and study the surroundings on their own and act accordingly to the surroundings. But the problem with these vehicles is the problem of path following, that is, the ability of a vehicle to follow a particular path on its own. It depends on n number of factors, obviously, but it raises lots of questions in high risk situations where it becomes important to define the priority levels for entities. Moreover, situations in reality are very varied and they are very dynamic. So it becomes necessary for the vehicles to be able to predict the situation and react to it in the safest possible way. So, in such cases, artificial intelligence plays a very important role. Let's talk about the applications of artificial intelligence. The first application is electronic speed control. It is an electronic control system which controls the stability of the car or the vehicle. For example, in turns, the stability of the car is a bit disturbed. So, what this speed control device does is this regulates the engine power and it brakes different wheels with different intensities so as to stabilize the whole vehicle during turnings. They are actually used to correct the understeering and oversteering situations. In understeering situations, the this device brakes the rear wheels inwards and then brings the vehicle into stability. The same happens in the case of oversteering, where the brakes are applied in the front wheel and that too in the outward direction so as to generate a mechanical movement in the correct direction. This is the role of electronic speed control. Moving on to autonomous emergency braking (AEB). This device comes into picture when the applied braking is not enough to stop the vehicle. So this device generates maximum power on the pedal or the braking system so as to stop the vehicle. In case if ABS is not activated in emergency situations, the system itself applies the pressure on the pedals. Even if the driver doesn't apply the pressure, the system itself applies the pressure on the pedals and also prevents the locking of the wheels. Now AEB is very much advanced. Like there is an infrared camera system which detects when a car is approaching nearer to a car over a speed of 30 km per hour. It automatically alerts the driver when the car is too nearer to the other car and also applies the brakes forcefully to prevent accident. Later moving on to traction control system. Traction is nothing but the slipping of wheels of the vehicles during acceleration. So this electronic device is used to prevent the slipping of vehicles. What happens is when a when there is a traction in a vehicle, the engine's torque is more dissipated on the wheels with more grips, bringing the wheels to stop. That is, the vehicle stops in case of traction. To solve this issue, there are many speed sensors which convey the information to the traction unit where it engages the brakes of the problematic wheel and then permits the energies of the engine or the power of the engine to be distributed overall. Even in the motor power, when the driving wheels begin to slip, the system engages the brakes on those wheels and reduces the extra torque and frees the wheels to take the advantage of the grip of the road. So this was about the traction control system. Let's move on. Let's talk about ABS, anti-lock braking system. It is the electronic control system of the vehicle that keeps the wheels from locking up. That is, it prevents the locking up of wheels. There is a encoder, that is, it consists of a transducer and a phonic wheel which is located on the each wheel. They are made up of gear wheel that rotates with the vehicle's wheel. The electronic control unit actually calculates the speed of the wheel's rotation, and if it notices the locking of the wheels while braking, it activates the hydraulic pump to reduce the braking force. The driver can also feel the vibrations of the ABS system when it is activated. These vibrations are brought because of the oil pressure in the braking circuit. But if the driver is startled by the pedal's vibration and if he releases the brakes before the application of brakes, then it leads to accidents. Because of this, some automobiles also use braking systems where they have an emergency braking aid. That is, the front axle is first lowered and then the part of the load is transferred during the brake, which increases the vertical force of the wheels significantly. When using ABS, the steering wheels also vibrates, so it is best to hold it firmly with two hands. Next, adaptive cruise control. ACC makes use of some radar sensors to find the moving on things which are ahead or behind of the car in the same path. Until the presence of other cars, the speed of the vehicle is at the fixed value. But as soon as the ACC recognizes other cars which are moving in the vehicle's path or which are very close to the vehicle, it will automatically lower the engine power, and if necessary, brakes are also applied so as to maintain a safety distance from the vehicle. ACC is basically a cruise control system that assists the drivers in maintaining safe distance from the vehicles that are in front of them. And they also alarm or alert them when manual intervention is needed. ACC automatically applies the brakes and also lowers the engine's power if necessary. If the driver's assistance is necessary to keep the certain distance, then alarm is generated. Let's move on to blind spot detection. Blind spot detection is the control system where it identifies the vehicles which are in blind spots. It is consisting of some sensors, cameras, and radars as well, which are mounted in the back bumper of the vehicle. So it alarms or warns the vehicle when other vehicle is detected in its range. Is there are various number of applications of artificial intelligence put together with machine learning. Obviously, these are very basic applications of artificial intelligence. Actually, the control system, electronic control system of these vehicles are very complex, and they are filled with n number of electronic circuits in it, and also huge programming is also required. Overall, artificial intelligence plays a very important role in e-mobility. So this is all we wanted to present today. Hope you guys liked it. Please like, share, and subscribe. Thank you. Park Assist. Park Assist actually supports the driver while parking in finding an appropriate longitudinal and transverse parking space. It measures the parking space and also with the dimensions of the vehicle, and then finds the best parking spot for the vehicle. The first step for park assist process is the measuring of parking space. It automatically interferes with the steering vehicle in the best way to park the vehicle. The driver simply has to just accelerate or brake the system so that to move forward or backward to the best position to begin with the operation. Modern automobiles have ultrasonic sensors, which are placed all around the car's exterior so as to determine the parking space precisely, as well as in the presence of any obstacles as well. The control unit will automatically calculate the available space and then build a virtual representation of the area around the vehicle, and then determine the operations which are required for parking. The electrical impulses are also created, which are converted into mechanical impulses that are capable in moving the steering wheel of the car by itself and also carry parking operations. Let's move on to Lane Keep Assist (LKA). Lane Keep Assist is actually created to guarantee the car to retain the road. That means the car shouldn't cross the lane or it shouldn't move outside the road. There is a video camera which detects the lane markings, that is the white stripes which are there on the road. And if the vehicle is getting too close to the white stripes, then the system automatically gently turns the steering wheel and puts back the vehicle into the appropriate direction. It is actually a very good um, implementation of artificial intelligence where it becomes necessary to keep the vehicle in lane. So this is actually the scenario of application of AI in e-mobility. Apart from this,